Pak Javin sekejap ya.
Baik, Dokter Norma.
Kita tunggu sikit.
The button, the panel, the sharing panels is supposed to be at the bottom. There's a share button, right? That I can share my screen. But for my iPad, there is no share button over there. Because I need to use iPad for me to, do some sort of writing during the lecture. So do you have any suggestion, Pak Jovian?
If from MacBook only is okay, Dr. Norma, if you want to take a time to setting your iPad to can writing, maybe
Okay.
I can help you for the sharing in iPad. You can share your screen or screenshot your.
Actually, okay. Now, like this one, I have two tools right now. I have MacBook and also iPad. Actually, I would like to use iPad in order for me to do the lecture, because of mathematics, we need to write equations and so on. But the problem is on my iPad. There is no button, share button. But for my MacBook, I can share my file, I can share my video and so on. There's no problem. Just for my iPad, there is no share button.
It's okay from MacBook, Dr. Norma. Uh,
For MacBook, there is meaning that I cannot give example and so on. I just do the
okay,
talking, you know.
okay, wait.
Or meanwhile, I have a video for the student to listen first. Maybe I show the video first. Is it okay? We can open the lecture, but I try to share the video first. Is it possible?
It's possible. You can share the video
Okay.
first.
All right. So while my colleague would like to try to see what happened to my iPad. Otherwise, I cannot do normal class like give example, teaching, explain the equations and so on.
It's okay, Dr. Norma.
Okay, okay. Boleh. Eh, Boleh ke?
Cakap mana doktor punya?
Document I isi sekejap. Share di sini. Macam mana dia buat?
Sit down dulu.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay,
Waalaikumsalam.
can you hear me?
Yes, Dr. Normah.
Is it clear?
It's clear. Doctor, let me open the case lecture.
Alright. Okay, alright, please.
Okay.
Okay, sorry, yeah.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay, good afternoon, everyone. With our distinguished guest lecture, respected lecture, dear student, welcome to the UGC or UNDIP Global Classroom program, organized by Department of Mathematics, Faculty of Science and Mathematics, Diponegoro University. Today, we are very honored to have an international guest lecture entitled Introduction to Fuzzy Set Theory, fuzzy number and arithmetic operation. Okay, this program is a part of Universitas Diponegoro's commitment to strengthen international academic collaboration and providing global learning experience for our students. Okay, it is my great pleasure to introduce our guest lecture today, Dr. Normah. Hello, Dr. Normah. Can you hear me?
Yes. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
I stop sharing first. Okay, alright. Maybe I should open my video, so that you can see me. Okay.
Okay.
So this is me. Okay. So nice to meet all of you. How many students you have right now?
I think it's almost 100, because coming from two class,
Okay, good.
50 each class.
Okay, all right. So it's very nice to see you. And thank you for inviting me for this global classroom session. So, all right. So I am. Do you want me to introduce myself again? So maybe I can just introduce. Okay, I am Dr. Normah Maan from Universiti Teknologi Malaysia. And then I have been teaching this fuzzy set theory. It's about, I think, more than 10 years. However, maybe the syllabus is a little bit different from what you have, okay, class. And I am not sure whether the fuzzy arithmetic is actually in your syllabus or not. Maybe from the description given by Pak Jovian, there is no stated that fuzzy arithmetic, but maybe it's embedded in one of the chapter. I'm not so sure about that. So, however, I really hope this lecture and this activity will give benefit to the student. That is the most important thing, because I'm glad to, to be invited to share my lecture and maybe some experience on this fuzzy set theory. Okay, that's all from the introduction. Can I just proceed to the lecture, or any other, opening or whatever, Pak Jovian?
I think it's we go to lecture right away. Yeah, the floor is yours, Dr. Normah. Yeah.
All right, thank you very much. All right, so before that, I think I stopped my video because I would like to focus on the sharing of my screen. Okay. Can you see my video, my screen?
Yes, Dr. Normah.
All right. So this is a fuzzy arithmetic for 2 days lecture, and I actually try to create this note as specific for this class, and 2 day lectures for UNDIP. Okay, so I also have this is basically code for us to do activity. Maybe not now, maybe later. Just some quiz for the introduction to fuzzy set theory, to see whether the understanding from the student perspective. Okay, maybe before we start the lecture, I think I just give the lecture overview. We have 2 days. One day is about 1 hour 30 minutes. Okay, Pak Jovian? Is it 1 hour 30 minutes, right?
Yes, Dr. Mark.
Okay, so it's around that. Okay, so what I can cover for this first day is a concept of fuzzy numbers. Okay, fuzzy numbers, Cripps interval, alpha cut representation, arithmetic operation on closed interval, addition of fuzzy numbers, and I actually go to subtraction, multiplication, extension principle, minimum and maximum of fuzzy numbers. However, this is just my proposed lecture, overview. Maybe we not really follow this one. Maybe we can skip some other topic which I think is not. Maybe we can shorten the duration and so on, depending on what actually the feedback from the student. Okay. So I also outlined the teaching or learning outcome. So we hope that at the end of this lecture, students should be able to explain the concept and properties of fuzzy numbers. So, but I hear, Pak Jovian, I cannot see any student from my screen here. There is no student here. Okay, it's okay. I just can see Pak Javian, but there is no audience, no other audience. Okay, never mind. It's okay. So number two, it's better if you can see the students. Okay. So number two, distinguish between the student should be able to distinguish between Cripps number, Cripps interval, fuzzy numbers, and fuzzy interval. Can be able to represent fuzzy number using this one, using a membership function, alpha cut, perform arithmetic operation on closed interval, compute fuzzy arithmetic using the alpha cut, explain the extension principle of fuzzy arithmetic, differentiate between fuzzy union, intersection, and so on. So, okay. So basically, this is the learning outcome that we expect for the student to achieve by the end of the global classroom session lah. All right. So, but anyhow, I do prepare a video for the student, maybe for you to listen first before we proceed to the first one, so that to motivate the student. And sometimes student would like to listen to the video first. Okay, so we try to see. This is quite very not too much. I think about 5 minutes video. Hopefully you can.
A GPS coordinate gives
Okay, is it okay? Can you listen properly? Can you hear
Yes,
from here?
it's clear, not Dr.
Okay, all right. Okay, so
you an exact point on the globe, down to the millimeter. But ask where a neighborhood ends and the next begins, and you get a gradient. Mathematical certainty is easy to plot, but real-world ambiguity requires a different approach. Here, panel A shows an exact point, and B is a crisp interval with abrupt drop-offs. Real-world data is rarely so clean. Panels C and D map fuzzy numbers. Their sloped edges taper gradually, proving a value can belong to a set partially. The y-axis measures degree of membership, how true a value is, scaling 0 to 1. To actually perform math on these sloping shapes, we use a tool called an alpha cut. We select a height, alpha, and slice horizontally across the triangle. This horizontal slice captures a flat line segment inside the shape. The alpha cut translates 2D geometric ambiguity into a 1D algebraic interval, giving us an equation we can actually plug into a formula. Because every alpha cut yields a flat horizontal line, we have to calculate them using the established rules of crisp interval arithmetic. You cannot do fuzzy math without mastering closed interval math first. Interval addition is straightforward. To add two intervals, you simply add their lower bounds together to get the new minimum, and add their upper bounds together to get the new maximum. Subtraction requires a cross-matching step. If you just subtract the matching sides, you calculate the wrong range entirely. To find the absolute lowest possible value, you must take your lower bound and subtract the upper bound of the second interval. To find the highest, you take your upper bound and subtract the lower bound. Multiplication expands this logic further. You multiply every bound in the first interval by every bound in the second, generating 4 possible products. You then extract the absolute lowest value to serve as your new minimum and the absolute highest to serve as your maximum. Crisp interval math focuses entirely on mapping absolute worst case and best case extremes. These rigid mathematical tracks are what allow us to safely process the sliding scales of fuzzy logic. Let's apply this to an actual problem, adding two distinct triangular fuzzy numbers a and b. We slice both triangles at an arbitrary variable height, alpha. When we extract the algebraic parameters along that slice, we get two interval equations. For a, the interval runs from 2 alpha minus 1 to 3 minus 2 alpha. For b, it runs from 2 alpha plus 1 to 5 minus 2 alpha. We apply our interval addition rule. We isolate the left sides, adding the two minimum bounds together. Then we execute the exact same process for the upper bounds on the right. The variables combine cleanly. On the left, the ones cancel out, leaving 4 alpha. On the right, we get 8 minus 4 alpha. Two overlapping ambiguous shapes have been combined into a single parametric equation. Addition was the easy part. Subtracting fuzzy number b from fuzzy number a forces you to use the cross-matching rule we covered earlier. Grab a piece of paper, pause the video, and see if you can calculate the simplified interval for a minus b. Keep the cross-match rule in mind. Let's walk through the solution. To find the lower bound, take the minimum bound of a and subtract the upper bound of b. To find the upper bound, take the maximum bound of a and subtract the lower bound of b. Distribute the negatives and combine the terms, and you get 4 alpha minus 6 for the minimum and 2 minus 4 alpha for the maximum. If you subtracted the corresponding bounds directly, you would generate a logically impossible interval, collapsing the entire model. We have our new interval bounds in algebraic form. But how do we turn those equations back into a visual graph for our final calculation? We convert them by setting an x-axis variable equal to our new bounds. We set x equal to 4 alpha and x equal to 8 minus 4 alpha. By solving for alpha on one side of both equations, we build the final piecewise membership functions, x over 4 and 8 minus x over 4. We plot those functions onto the axes. By slicing the initial shapes into intervals, calculating the extremes, and solving for alpha, we map the exact geometric shape of our combined uncertainties. Fuzzy arithmetic follows a strict operational loop. You extract geometry down into flat interval algebra, compute the bounds, and pull the algebra back up into geometry. This chart summarizes the entire process. Take a screenshot for your notes. On the left is the visual dictionary mapping exact numbers, crisp intervals, and fuzzy boundaries. On the right are the 4 mathematical rules required to manipulate them. Ambiguity usually stops a calculation in its tracks, but with alpha cuts and interval arithmetic, uncertainty is just another variable you can control and quantify.
Okay, so any questions from the student, or this one is one-way lecture? Can I get feedback from the student first before we start to the next lecture? I mean the next. Pak Javian, I just did is one-way lecture, is it? I cannot actually get response or feedback from the student.
Ayo anak-anak dijawab ya. Di sini mahasiswa-mahasiswa, ayo dijawab Dr. Normah ya. Ketika ini sudah paham belum? Sudah ya jawab sudah Bu. Ya.
Okay. All
Oke.
right. Okay. So any
Gitu.
questions regarding to the video just now? The video explaining about fuzzy number a little bit, the differences between crisp number and fuzzy number, and then how to calculate, especially on the addition of fuzzy number, and so on. And never mind, we try to do it one by one. Maybe it's not comfortable, or I see maybe the system not allow the student to give the feedback, since I think you are in one room, right? Not individual using a laptop or whatever, right? So you are actually in a classroom. Maybe it's not easy for you to respond my questions. So it's good if you can have, two ways respond, meaning that I know that I am not alone here. So never mind. So we go to the next one. This is why fuzzy numbers. Have you discussed about fuzzy numbers before, Pak Jovian? Before this, have you
Yes,
discussed in class?
we
No,
have
no.
a meeting 12 times about the syllabus that
Yeah,
sent to
yeah,
you.
yeah, yeah. What I mean is this fuzzy, the word fuzzy numbers. Have you come across or not yet? You discussed about fuzzy set, right?
Yes, Doctor.
Not, okay, not fuzzy number. Okay. So fuzzy number basically for the student information, right? So the fuzzy numbers actually is a fuzzy set. But there are extra properties that fuzzy set can be said as a fuzzy numbers. So meaning that fuzzy numbers is a fuzzy set with a certain properties. After this, I will explain to you what actually the properties. So then here, as an introduction, I gave you classical mathematics. You heard about number before this. Can you see my cursor? Can you see the red cursor that I showed to you from
Yes,
the screen?
we can see
Okay,
Yes,
okay.
Doctor.
the pointer. Yeah.
All right, thank you very much. So you can see my cursor, right? My cursor is moving right here to show a number. So I think everyone of here definitely familiar with the word a number. Okay, now we are talking about fuzzy numbers. So number here, we also can do the arithmetic operation on number. Like for example, 2 plus 3, that one is operation on a number or a Cripps number. Now is we want to see how to do the arithmetic operation on fuzzy numbers. So maybe because fuzzy number have a very special properties. So it's not like a Cripps number. So the methodology how to do the calculation, to do the operation, the arithmetic operation, addition, subtraction, multiplication, and division, a little bit different, and then there is a specific methodology on that. So now looking into this one, a number is exact. For example, x is equals to 10, x is equals to 5, and so on. Okay. However, in real situation, we often use approximate expression. This one, you know that, for example, a number which is approximately equal to 10. So this is not exact numbers, but approximately equals to 10. And another example, maybe I can say about what time is our meeting? Like for some, you set a meeting. So maybe someone will answer like our meeting is approximately equal to 2. So when we use the word approximately, so meaning that the number is not an exact number, it's approximate. So meaning that there is some sort of fuzzy here, which is not clear boundary about approximately equal to 10. So that's why we can categorize this one as a fuzzy number. And then another, yes, any question? Any question not there? So this
no,
one
no.
okay. So around 50 years old. So maybe some people ask you, how old are you? So my age, maybe I can say that. So I am around, about. That one is actually representing fuzzy. So, and also when we talk about temperature, so what actually how is the weather today? Maybe you can say cloudy, high temperature, something like that one. So this is actually we can consider as a fuzzy. And then this one is low risk, for example. So you can also represented by a fuzzy numbers. So in other way to say that a fuzzy numbers represent an approximate numerical value using a membership function. When we talk about fuzzy number, we can actually represent that fuzzy number using a membership function. So as you know that fuzzy number, fuzzy set is a fuzzy, right? But the membership function is not fuzzy. The membership function that can represent any fuzzy set is not fuzzy. Okay, so that one is you need to understand and distinguish between that term used in this fuzzy set concept. All right. So now we go to definition. So a fuzzy set, so the one that I mentioned just now, fuzzy set A defined on the set of real numbers R is called a fuzzy numbers. If it is satisfied, there is three conditions here that I mentioned just now. Fuzzy number basically is a fuzzy set, but must satisfy a certain properties. The first one, A, is a normal fuzzy set. Normal fuzzy set meaning that the highest value or fuzzy value should be equals to 1. And A alpha, this one, I think everyone of you recognize this term. D is actually the symbol of alpha card that we use. Okay, D is alpha card of a fuzzy set A is a closed interval for every alpha. So meaning that alpha card of a fuzzy set, in this case, if you want to define that fuzzy set is a fuzzy number, you must ensure that all the fuzzy card, all the fuzzy alpha card, okay, between 0 to 1 must be a closed interval. Okay, and then the third one is the support of A denoted by A subscript 0 plus here is a bounded. All right. So interpretation of these three properties, every fuzzy number is a convex. Convex is actually representing this. Okay, convex set with bounded support. So normal and convex, basically we can say that every fuzzy number is a normal and convex fuzzy set with bounded support. So actually this one is a normal and convex fuzzy set with bounded support. Okay? So far so good, class? Yes. Okay, I ask question and I answer for you since you cannot answer the questions. Okay, this one, Fatia Gina Nava. How are you, Fatia? I see from the screen your name.
I'm fine, doctor. Sorry.
Okay. So now we look into this term that we use, Cripps number, Cripps number, Cripps interval, fuzzy numbers. Okay. So there are three important terms here that you must be able to distinguish. The first one is Cripps number. So Cripps number is something like just now we mentioned about number which is equals to 10. That one is a Cripps number. So like for this one, exact value, Cripps interval value lies within an interval. For example, like this one, D is we call it as Cripps interval. And then fuzzy number, when we refer to the first example here, we can actually use the word approximate value. For example, number close to 1.3. So when you see the word close to 1.3, meaning that actually representing fuzzy numbers. Okay, so fuzzy interval here actually is interval with gradual boundary. I will show to you in terms of diagram. Okay, like this one. D is actually Cripps number. When that number is equals to 1.3, so we can see that D is maybe D is 1. Okay. So meaning that number 1.3 belong to the set, that set Cripps number where the membership value is equals to 1. The number is not equals to 1.3. The membership value belong to that set is equals to 0. Okay, so this is how you you define. Normally, let's say, okay, class, hold on. I put on my table, so easy for me to write down. So just now, okay. Hold on. Dia dah terlampau banyak, okay. Okay, tadi. We are here, right? Okay. Okay, you see here. Okay, this one, you know, D is 1.3. D is basically 1. So D is you can say that, let's say that this set, we let as A. So when X is equals to 1.3, X here is equals to 1 if X is equals to 1.3, 0 otherwise. So we can describe your single value like this one, okay, as a membership function of that particular set. A is a set contain number X is equals to 1.3. So when X is equals to 1.3, so the membership value will be equal to 1, 0 otherwise. So this one also the same thing. We know that mu, let's say D is a set B. Okay, let's say you see this one, let's say B. Let's say B here is equals to 1.25 and 1.35. So basically, you can also identify the membership function that representing this one. Should be no problem. You can identify as well. Okay. So this one is a fuzzy number when we mention about approximately equals to 1.3. So this is one example how to represent this fuzzy number 1.3 in terms of membership function. So we have something like this one. So or you can also represent this in terms of very sensitive. Actually, this is my new iPad. First time I use together with you. So there is okay. So there's very sensitive. Mm. Mm. Okay, so actually there are a few you can represent your fuzzy number close 1.3 with a few representation depending on what actually application that you want to use. The one that I show to you just right now, basically we use this curve. We use this curve to represent the number close to 1.3, but actually definitely I can use other representation. Let's say D is 1.3. So I use like a triangular membership function. So meaning that when X is equal to 1.3, so the fuzzy value is equal to 1. Other than that, it will follow the equation of this line, and so on. Okay. Okay. So now look at the fuzzy interval. So D is actually Cripps interval. D is a fuzzy interval. So this one again, actually you have not to fix to any membership function. So you can define perhaps the definition that you define for your fuzzy number must be able to represent the application that you want to solve. So in this case, we use a curve also like this one to represent the fuzzy numbers or fuzzy membership function for this fuzzy interval. You can always use trapezoidal, which is the graph will be like this one. Okay. So where here is supposed to be 1.2, here is supposed to be 1.28 here. And then the other hand here is a 1.32. So this is actually 1. So you must remember fuzzy number is a fuzzy set which is normal and then convex and also bounded. Okay. So this is the properties that I already talked about: normality, convexity, and bounded support. So this is also just to show to you another representation to explain this one. So the first one is the first property number 1 here. Property 1. So here is talking about normality. This one talking about convexity. So convexity of when we talk about convexity of a fuzzy set, meaning that you must ensure that all the alpha cut A alpha must be a closed interval for every alpha, where alpha definitely between 0 and 1. So this is the definition of convexity. And for your information, this is very important for you to digest, to understand the convexity properties, because when later on, if you already complete your courses for the fuzzy set theory and other courses, maybe you want to further your study on research, then you want to use the fuzzy set theory concept in your research to apply on certain application. I think when you try to represent the problem in terms of fuzzy numbers here, you before the calculation, you must ensure that the fuzzy set that you want to solve must be a fuzzy number which is satisfy the properties of convexity, because that one is very important to ensure the existence of your solutions. Okay, so and then the third one is bounded support. Okay, so this is the way we try to represent our concept of properties of fuzzy number. So normality, convexity, and bounded support is 3 important properties for a fuzzy set to be satisfied if you want to say that fuzzy set is a fuzzy numbers. Okay. So this one another example that maybe I can show to you. When we said that bounded support, so you must make sure your left hand side here is non-decreasing monotonic function from the base up to the core, and then this one there must be take value 1 here, which is normal, and you must make sure your right hand side of your slope here actually non-increasing monotonic function from the core down to the base. So this is the concept that you need to understand when you talk about fuzzy numbers. We talk about fuzzy numbers. Fuzzy numbers again is a fuzzy set. It's a fuzzy set, but that fuzzy set must satisfy the normality, the convexity, and then also the bounded properties that we mentioned just now. And we know that if D is A and D is B, so let's say if A is equal to B, so meaning that this one will be a triangular membership function or triangular fuzzy numbers. Okay, if A is equal to B. Okay. So this is a general form of fuzzy numbers. So this is actually definition of triangular membership function. So you can see here, let A be a fuzzy numbers, then there exists a closed interval AB, which is definitely AB here is not a null set such that we can say that X here, the membership function of A for this particular X is between this one is equals to 1. So, and the rest here is the function Lx, okay, from negative infinity to A, and then R left function, right function. So you must remember here, this one is monotonic increasing, this one is monotonic decreasing. So if this satisfies, we can say that all this one is a convex fuzzy numbers or convex fuzzy set. So this I just repeat a few things here. So okay, here again as an example, we just substitute. If you refer to many references book, when they talk about a triangular fuzzy number, they always define that fuzzy number in this form, okay? A, B, C, for example, A, B, C. There are three tuple of A here, but D is not a coordinate. But D is another way to represent A, where A is a triangular fuzzy numbers. So A here, when we mention, when we look into this one, you should know that if I ask you to sketch the diagram, so I think you should be able to sketch. So 1.2 is supposed to be here. 1.4 is here. D is 1.3. So meaning that this line of this equation representing this one, and then this one actually representing this. Okay. So this one is trapezoidal fuzzy numbers. So again, if you refer to many reference book, so okay, I also like to, from my experience teaching this fuzzy set theory, there are quite a limited fuzzy set theory reference in terms of the variety of references, because sometimes when we look at reference number A, reference number B, reference number C, how they actually define the fuzzy set, sometimes they are using different notation and so on. The consistency is not there. So another thing, the example I think quite similar. If you refer to 10 books, so 10 books talking about the same example. So there is a little bit limitation, especially for the lecturer, if they want to do to use the reference book as your lecture notes, maybe you need to simplify it so that the student is easier to understand. And also for the student point of view, be careful when you look at the other reference book outside, because sometimes the notation they use is different. Then what you need to do, you need to see and understand the definition of that notation for each of the book that you refer to, okay, to avoid from you get confused. So this one actually for trapezoidal fuzzy numbers, we have four numbers here, which is when we represent this one in terms of diagram, we can see that something like this, okay? So here is supposed to be, from that is 1.28, here 1.32, and then this one is 1.4, and then the rest here is 1.2. So when you look into this next time, so meaning D is trapezoidal fuzzy numbers, and you should be able to represent this in terms of this equation, class. Because sometimes when we want to do the calculation and so on, it's also necessary for you to represent the trapezoidal or triangular fuzzy numbers in terms of arithmetic equation like we have here. Okay. So this is actually the same thing. We just represent in another point of view. Any questions so far? So okay, tak ada so no problem. So ni alpha cut of fuzzy number. I think alpha cut before this of fuzzy set, every one of you have come across. So now we are talking about alpha cut of fuzzy numbers. So again here, since fuzzy numbers is a fuzzy set, so the definition to get or to define your alpha cut is similar to the one that you have before this, which is alpha cut of fuzzy set. Okay, so you see here, alpha cut actually is a crypt set. It's not a fuzzy. It's not a fuzzy set. Alpha cut is a set. Alpha cut is a set, or more specifically, alpha cut is a crypt set. Okay, it's not a fuzzy set. Alpha cut is a crypt set, which is in this case is in this general definition, we can say that A alpha here is number of X here, where X is real, and then where the membership value for A, for that set A, for the fuzzy set here, for X should be greater than equals to alpha. So that's why when we try to see, let's say I sketch here, triangular fuzzy number. So let's say this one 1. So let's say this one alpha, this one x1, this one x2. So basically, when we want to say that A alpha, in this example, so A alpha is between x1 and x2 here. Okay? Where you can see any element from S1 and C2, and when you put inside the mu A x1, definitely the answer, the alpha cut should be greater than equals to alpha. All right. So for a fuzzy number here, we can represent our fuzzy alpha cut here in terms of this notation. So A alpha superscript negative, meaning that the smallest value, okay, A alpha, the superscript positive is the biggest value, okay. Something like this. All right. So this is just to, the alpha cut representation. So we consider like slicing the mountain. This one just the word mountain that we use here just to describe because we talk about convexity, normality, and so on. We just imagine like that one is like a mountain, and then if you want to represent the alpha cut, like you slice the mountain with a specific values now, where the alpha here is between 0 to 1. Okay. So here alpha cut of triangular fuzzy number. So we have this, and then as usual, we convert this representation of triangular fuzzy number in terms of this one. So I think everybody should understand here. So definitely you no need to memorize in this case. You need to understand very simple concept, algebraic mathematical concept. So you have here 4, this 1, 2, and 6. This is very, very simple. So this equation actually representing this line. So you have 2 points here, definitely you can get this line. And then the other one here representing this one. So I think there should be no problem for you to find out. And then after that, A alpha should be equal to 2 plus 2 alpha, 6 minus 2 alpha here, exactly as what in the video. And I believe that you also have come across with the Pak Javin before this, how to calculate A alpha. So there's no questions, right, for this one? So then we want to see the arithmetic operation on fuzzy numbers. Our main is objective to do arithmetic operation on fuzzy numbers. So before you try to do the arithmetic operation on fuzzy numbers, our scope is basically to do this, okay? arithmetic operation here on fuzzy numbers, okay? On fuzzy numbers. But there is, for your information, there are two methodology or two method to perform this arithmetic operation. The first one we call it as alpha cut method. So in alpha cut method, what you need to do when you have two fuzzy numbers and you want to do the arithmetic operation, first step you need to find out the alpha cut of each of that fuzzy numbers. Okay, because we need to do the operation on that alpha cut, and after that we use first decomposition theorem. I just would like to know whether you have come across first decomposition theorem before this. Pernah dengar tak first decomposition theorem? Anak-anak pelajar, pernah dengar tak perkataan first decomposition theorem? Pernah dengar? Boleh memberi jawapan? Arum istiqomah. First decomposition theorem. Have you heard about this before? No answer. Okay. Okay, by the way, can you listen to me or what? Can you see my slide? Is my slide moving or what? Or stagnant?
Moving, Dr. Normah.
Wait, so far so good. You can follow the lecture, right?
Yes, yes.
Meaning that maksud saya the slide is moving, right?
Yes,
So
yes.
I'm afraid that the slide is stagnant. Okay, so then it's good. So okay, class. I'm not so sure. Sorry, Pak Jovian. I just asking whether the student already come across first decomposition theorem or not before this.
Yes, we have a discussion.
Okay, good. So because in order for us to do arithmetic operation on fuzzy number, when we use the alpha cut method, later we need to use first decomposition theorem in order for us to get our results, to get back the algebraic equation representing A plus B if A and B are fuzzy numbers. So now, as I mentioned, we need to understand the basic concept of closed interval first, like we have here, but I don't want to actually discuss this one too much because it is very simple. And for the division, you must understand that 0 must not in the denominator. Okay? So this is an example for interval arithmetic, but I don't want to, discuss further. This is very simple one. Yeah, this one also the same thing here. Okay, we just give more definition, more example, but that one is quite straightforward. So also with the multiplication. So basically, when you do the interval arithmetic and on interval, Cripps interval like what we have here. Okay, like what we have here, something like this one. Okay, so what you need to do, basically the results here will be the minimum one. Between all the combination, this one is the maximum one. As what in the video, you need to find all the multiplication of this one. Be careful, especially involve negative. If the interval is negative value, so the minimum and maximum, which one that you want to identify the minimum and the maximum of that combination is very, you need to be more careful because I'm afraid to avoid any mistake. This is the only thing lah. Okay, so the same case with the division. Okay. So now we try to see the definition of fuzzy arithmetic operation on fuzzy numbers. Okay, so let's say A and B here. A and B denote as a fuzzy numbers, and let star here denote any of the four basic arithmetic operation. So either addition, subtraction, addition, subtraction, multiplication, or division. Then we define a fuzzy set on R, A star B here by defining its alpha cut. So this one we have here. So in other way to say, if we have two fuzzy numbers, when we want to do the arithmetic operation, so we need to do operation on fuzzy on the alpha cut first. Okay, so as I mentioned, there are two methodology. First, we use alpha cut method. So I write down here, alpha cut method, or we can say like something like this one, arithmetic operation. Arithmetic operation. So we can use alpha cut method. And then another one use extension principle. So when you use alpha cut method, you need to convert or you need to represent your fuzzy numbers in terms of alpha cut. You need to find alpha cut first. Then you do the arithmetic operation on alpha cut. After you got the answer, then you need to use the first decomposition theorem as I mentioned to get the final answers. Okay. So this is that I mentioned here due to the first decomposition theorem. So, but yeah, of course, this one not in this one since you said that you have come across. So meaning that we can get this. Okay, let's say this one is equals to C. C is the fuzzy numbers that you obtain after the arithmetic operation. So what you should have is you need to do the union. Okay, of all the alpha cut of that particular of all of the alpha cut of A multiply B here. You need to find all the alpha cut, then you do the union, then you will get your C here. So this one we can say that we use the first decomposition theorem. All right. So this one we specifically go to addition, but I think the same definition that we mentioned just now. So then similarly with the subtraction, so maybe this one also I define one by one. Of course, in order to use alpha cut method, you want to use alpha cut method here. Okay. Okay, what you need to do, the first step, you need to define the alpha cut of each of your fuzzy numbers. Okay, then you calculate, you apply the standard interval arithmetic to these horizontal lines. Okay, and then reconstruct. So when you want to reconstruct this one, we can actually use the first decomposition theorem. Okay, this one you use that. So now go to the example. I think I also provide my lecture notes, which is I try to simplify it. Okay, maybe Pak Jovian can share that. Okay. So this one, yeah, the first thing that you need to do here when you got this kind of problem, this is from the definition of membership function here. we can see that both A and B are triangular membership function or triangular fuzzy numbers. So if you want to do the arithmetic on addition operation of these two fuzzy number, so what need you to do is you need to find what actually the alpha cut of this. So in order to do that, I think it's quite straightforward as well. So I think everyone have be able to find the A alpha here, okay, which is in this case, you look into this equation, okay, you can say that your x, your alpha is equals to x plus 1 over 2. And then you want to find, because you know the alpha cut actually is a crypt set. It's the set which contain the value of x. So now you will try to get your x. So this one you will get your 2 alpha minus 1, right? Here, when you simplify this equation, you try to get your x. It's supposed to be 2 alpha minus 1, which is equals to x. 2 alpha minus 1 or 2 alpha x minus 1, right? Am I correct? Right, okay. So the second part is you have 3x, okay, over 2 is equals to alpha. So you get your x, you will get your 3 minus 2 alpha is equals to x. So here you will get 3 minus 2 alpha. Okay, this is your alpha cut for A here, A alpha. So the problem, I don't know how your program will focus on. So I'm not so sure whether this kind of calculation is important for the syllabus or not. But basically, this is how we do. If you understand the important thing, you need to understand the methodology, how the calculation is work. So afterwards, when you can actually use computer programming and so on, when you try to solve a real application where you need to, do this arithmetic operation on that particular application or real world problem. Okay, so you have these two, A alpha, then the same thing that you need to find your B alpha here. So you need to find your B alpha here. So when you try to find B alpha, so the same procedure that you need to do, x minus 1 over 2 here is equals to alpha. Then you will get x. Okay, this one will be 2 alpha. Okay, 2 alpha plus 1, right? So, and the other one is, the other part is 5 minus x over 2 over alpha. So you will get 5 minus 2 alpha. 5 minus 2 alpha. So you have A and B here. So then what you need to do, you try to find A plus B. Let's say this one is equal to C. So in order to get this, what you need to do, you need to find C alpha, meaning that A alpha plus B alpha first. So this is the step, the methodology, okay, the procedure. So in order, since this is very straightforward, is addition operation. So the lowest part will be the lowest of the results of your what we call it, this one, the results of your arithmetic operations. So you will get 2 alpha, you will get this one. Okay, you add with this one, you will get 4 alpha. So you get 4 alpha. So this one left, your right hand side will be 3 minus 2 alpha plus 5. So you get 8 minus 4 alpha. Is it correct? Is it correct? Eight minus 4 alpha. So here that I mentioned just now, this is your C alpha or A alpha plus B alpha. So we want to get what is our C. So from here, we want to get what is our C. C is equals to A plus B. Okay? So to get C here, so D is the one that you need to consider. You need to use the first decomposition theorem, which is the first decomposition theorem state that D is actually from 0 to 1. You will get C alpha here. D is multiplied by alpha. So you need to use this one to get. So in other words to say, because D is actually the theory that you need to use this one. So, but how to calculate it is, so this is the one. So this is the answer just now. Okay. So we have just now A plus B. A plus B, okay, A plus B alpha. We have something like is equals to 4 alpha. 4 alpha, 8 minus 4 alpha. Okay, so you will get X is equals to 4 alpha. Okay, this another X is equals to 8 minus 4 alpha. So now you want transform in terms of alpha is equals to X over 4. Exactly like the example that I showed in the video just now. This one you get X minus 8 over 4. So this is your alpha. Okay, so is it correct? For alpha, sorry.
X minus X, I think.
Yeah, you're correct. You will get just now what? 8 minus X over 4. So you have these two, okay? So meaning that your A plus B by first decomposition theorem. So you get A minus B here, which is equals to C, which is equals to this function. X over 4, 8 minus X over 4. This one is for your X between 0 and 4. This one is supposed to be your X between 4 and 8, 0, otherwise. So basically, you can even sketch your diagram, okay? So you will get 0, 4, 8 here. So you can sketch something like this. Okay, this is 1. So this is your X here. So you can basically show from A and B, then you will get C. C is this one. So you see, this is a very important to note that why arithmetic operation is only work for fuzzy number. It's not fuzzy set. It's a fuzzy number. To actually maintain the convexity. The meaning to ensure the solution is there. Okay. All right. So now we go to the next one. So this is another example, but I think you can try on your own, because I also provide, I also provide some notes and also exercises at the back at the notes. You can try on your own, class. So this is maybe I put in other way to the methodology one by one. So maybe you can refer later. So the same case with the fuzzy subtraction, the same case, class. So fuzzy subtraction also, what you need to do is basically exactly the same thing like previously. Then finally, before you need to use the first decomposition theorem, transform your alpha cut of C tadi, C alpha tadi is equal to C. Sorry, from C alpha, you use first decomposition theorem to to get what is your C. All right? Anything else? Anything before I think the subtraction is tomorrow, but I would like to introduce another method to be used in order for you to calculate or to perform the arithmetic addition and subtraction. Okay, but in this case we use extension principle. Maybe it's better like that. Yeah, we settle with A plus B or A minus B using alpha cut method. Then we continue A plus B, A minus B using extension principle. So tomorrow we focus on multiplication and division. Is it okay?
Okay, Dr. Normah.
Okay. So when you look into this, the alpha cut method, what actually you can conclude? The method can be used to do the arithmetic operation, especially for the fuzzy number, which is continuous fuzzy number, right? So if you have where your fuzzy number, you can represent as arithmetic equation as what we mentioned, for example, like triangular membership function, trapezoidal membership function, which is that one is continuous. Like we have in this diagram, okay, like what we have in this diagram, we can see D is basically continuous, okay. So when we want to try to see if we give you like this example, like this example, like for example, I just give a very general example. Let's say we have A is equals to, sorry, I don't want to show, I don't want to use this. Okay, let's say we have 1 plus 2 plus 3 plus 4, for example, plus 4. So let's say this one is 0 plus 5. Let's say the 0. Let's say this one 0. This one, let's say 0 0.2. This one, sorry, this one 0 0.5, for example. This one is 1. This one is basically 0 0.3. This is only an example. So you have another one, let's say B. So B is another in this form. D is, we call it discrete fuzzy numbers. Okay, where we actually, the element inside the set is basically in the form of natural number bulat, 1, 2, 3, 4, 5, integer. All right. So how would like to do the addition, arithmetic operation, or subtraction, for example? So here is come the second method, which is we call it as a first extension principle. So what does this extension principle state? That we have this extension principle. Okay, method. So you can also refer to my notes, okay? They said that let A and B denote by A and B fuzzy numbers. And the star denote by the basic operation. Star is the arithmetic operation. Then we can define on the set R, for example, A star B by the extension principle, which is, let's say that is Z here, is supremum Z is equals to X star Y of minimum AX and BY. So this is what this extension principle means. So AB, fuzzy numbers. Star is arithmetic operations. Okay, either multiplication, division, subtraction, addition. So we are using the same formula. So A star B will be A star B, Z is equals to supremum Z is equals to A star Y. Z here is depending on what actually this operation is. When we now concentrate on addition, so Z will be equals to X plus Y. When we actually do the subtraction operation, so Z will be equals to X minus Y. If you do multiplication or division, so star here will be multiplication or division. But the other formula will remain the same thing. So if I can give you one example here, let's say we just take the example from the notes. Okay, let's say I need to consider 2. A is equals to 0.1 over 1 plus 0.5 over 2 plus 1 over 3 plus 0.7 over 4. Then you have 0.3 over 5. Okay. Then you have another fuzzy numbers B 0.1. Okay. Plus 1, 2 plus 0.5 over 3. So what you can say that A plus B here using that extension principle method, okay, with the formula that we give to you. So from this addition of A and B, we need to identify which element is the minimum one. So here definitely the minimum will be 2 because here 1 plus 1, you will get 2. So the maximum will be 8, right? Am I right? Yeah. The maximum will be 8 here. So you get plus 2, plus 3, plus 4. You need to calculate plus 5, plus 6, plus 7, and the final one plus 8. So when you want to get the 2 here, you want to get this 2. You know the combination here, you can get is only this element. This one, the one here, plus the one here. So it's equals to 2. So what if you refer back to this formula, you know that you need to find minimum between AX and BY, where X plus Y is equals to Z. So now you have 2. 2 is equals to 1 plus 1. 1 plus from X, and this one is from Y. So from here, we need to identify which fuzzy value of A1 from X here, which fuzzy value from Y, which is Y here is equals to 1. This is Y. Which one is the minimum one? Okay, so in this case, since the only one possible value here, so the answer will be class 0.1. So when you want to get this one, 3, so the possible one is this one plus with this one. And then also another possibility you can choose is either this one with this one. Okay, so the answer will be if you choose the first one here, or maybe you choose this one, this element plus this element, you choose which one is the minimum one is 0.1. Okay, either this one and this one, you choose the minimum is 0.2. From these two, you choose the maximum, which is in this case is 0.2. So the answer here will be 0.12 plus 0.23 plus the 4 4, and so on. So the same procedure that you need to do in order for you to get the answer. So you need to proceed with the calculation of what actually the fuzzy value for element 4. Element 4, the combination you can get 2 plus 2, only 1. 2 plus 2, or 3 plus 1, or another one, 1 plus 3. So there are three possible value that you need to look into, 3 combination of that. So you need to choose which one is the maximum. Any questions for that? Can you understand? So let's say your z is equal to 4, okay? So you need to think about, sorry. So let's say now you think about your z is equal to 4. So when your z is equal to 4, to get 4, the combination may be 1 for x plus 3. So another combination is 2 from x plus 2 from y. So another combination is, maybe you can say that 3 plus 1. You'll get 4. Okay? So between 1 here, 1 and 3, you must look at which the minimum fuzzy value. You should choose 0.1 and 1. So the minimum will be 0.1. This one, minimum 2 and 2. 2 and 2, the minimum is 0.5. So 3 and 1, minimum is 0.2. And then from here, you need to choose which one is the maximum. So the answer will be 0.5. So here will be 0.5. Okay? So understood how this one work? Okay, any questions? You can also do the subtraction. Okay, A minus B. Maybe I give you 5 minutes class to look into the possibility. The same, we try to use the same example and try to get example, right? This one. Try to find out A minus B. With the same A and B just now, we try to get A minus B. Okay, I ask you what are the minimum element that you can produce? Z, the minimum Z. What is the minimum Z? We refer to this one first. Now we are trying to get A minus B. A minus B, so this is Z, right? So here Z. Z meaning that to get Z is X minus Y. So which one is the, which element of Z that you can produce the minimum one? The minimum value of Z. So X minus Y. Remember X minus Y? What is X? What is Y? X is equals to 1, 2, 3, 4, 5. Y is equals to 1, 2, 3. So Z is equals to X minus Y. So what actually the minimum Z? 1 minus 3, right? So 1 minus 3, you will get minus 2. So this one will be minus 2, right? So you will get minus 1. You will get 0 plus 1. So look into this one back. What actually the maximum? Because you want to do the arithmetic subtraction A minus B. A meaning that when 5 minus 1, 4. 4 is the maximum one, okay? So you get the plus 2 plus 3 and final one 4. So this is the one. But the rule is still the same, meaning that in application, in real application, if you need to do this kind of operation, you can always use programming, MATLAB. You can use any simple programming to produce what is this. Okay? What is this? So the same procedure, the same formula you use, meaning that you need to consider this formula. But in this case, when we talk about the subtraction, meaning that this star will be the minus notation. Okay? Can you do this one later? Any questions? Any question from the student? Do you have any questions? If you don't have, okay, we go back to see this one. Maybe class, you can go to the quiz here. You can scan. You can scan this one. Okay. So you can go to the quiz. Mm. Can you go and take the quiz?
Okay, wait, doctor. Wait, miss.
Okay, okay. I'm not so sure whether you can get or not. Or maybe you can join, you can start from here. Can you see my screen?
Okay, wait, miss. 5.
Okay. We wait for the student to join the quiz, okay? It's okay. You can take your time. Okay, can I start? Not yet. So how many student already? Baru 22.
Hmm.
28. So Pak Jovian, I need to wait until how many student to join the quiz?
Okay, maybe 40 is enough.
Alright, okay. Okay. How is it the material is easy? Yeah, is easy, right? Have you come across you already teach the student?
Yes, yeah. But for the triangle Fuzzy number is not yet trapezoidal because it's advanced theory for our undergraduate thesis, so it's new for us. Yeah.
Okay. So remember, this is arithmetic, which is we cannot apply to any fuzzy set. We can only apply the arithmetic on fuzzy numbers, which is convex and normality. That two properties must be satisfied first to ensure that there is the existence of the solution. So this is before you perform the arithmetic operation on fuzzy set, you must make sure the fuzzy set is convex and normal and also bounded. Yeah.
Yes. Okay, it's already 40.
All right. Okay. You can start. Next. How to do? Is it you do it on your own or what? You use that you can answer everything on your own, right? So because I cannot see the marks. You still on number one or what? You already answered the question, right? But Jovian, you already answered the question number 2, number 3, and so on.
Yes.
Okay. All right.
Fourth question.
Okay. So have you done? Have you finished the game? Because I don't know why I cannot see the, have you done? Not yet. I cannot see the score. Normally I can see the score of my students. Okay, finish, done. So this one just for for games. Unfortunately, uh I cannot see the screen. I cannot see. Unfortunately, I cannot see who actually got the highest mark. Hello? So Javian, what actually your score?
Okay, I
Pak
will
Javian.
send it to you. Yeah, I will share screen
Sorry, you are still doing?
with
Wow. So who got full mark? Hazel. Congratulations.
Hazel. Hazel.
So,
Hello.
And yeah,
okay,
it's
congratulations to Hazel. So meaning that you understand full about fuzzy set theory. I just include the fundamental fundamental theory of fuzzy set theory to ensure that the student actually understand what actually fuzzy set theory, what actually the concept and so on. So congratulations to Hazel, Haura, yeah. So Aziza, you got 12. So and also the rest. Okay, you can try again later on. All right. So okay, Pak Jovian, I think if you don't have anybody of you don't have any questions, maybe
Woi, anjing.
okay. I leave it to Pak Jovian to I think today class I done already to achieve the target topic, which is the subtraction and also the addition of fuzzy number using two methods. We use alpha cut method, and also we use extension principle method. So alpha cut method specifically we use when the fuzzy numbers in term of continuous one, and then the extension principle normally we use when the fuzzy number is a discrete fuzzy numbers. Okay, so tomorrow we continue how to do the multiplication and also division, And also another operation which is operation on letters, which is maximum with capital letter and minimum with capital letter. So tomorrow we can see actually the minimum and maximum with the lattice operation there. Basically, it's not the minimum and maximum with the union and intersection operation that maybe you have come across before this. So with that, I just give back to Pak Jovian. Thank you very much.
Okay, thank you very much, Dr. Normah Maan, for the wonderful and insightful lecture today. We truly appreciate your time, kindness, and valuable knowledge shared with all of us, yeah, through the UGC or UNDIP Global Classroom. Yeah. Okay,
All right.
and on behalf of the Department of Mathematics, Faculty of Science and Mathematics, the Universitas Diponegoro, I would like to express our sincere gratitude for your meaningful contribution and collaboration. Okay,
Okay.
we also hope that this academic engagement will strengthen the collaboration between Universitas Diponegoro and Universiti Teknologi Malaysia and open more opportunities for future academic and research collaboration. Okay, to all
Okay.
students, thank you for your participation and attention throughout the lecture. I hope everyone gain useful knowledge and valuable insight from today's session. Okay, Dr. Norma, we would
Um,
also like to apologize, yeah, if there were any shortcomings during the lecture. Okay,
it's
one.
okay. The most important thing that the knowledge that I try to give actually is the one that you are need. So I'm afraid also because I don't know what actually you cover. You give the all the topic, but I'm not so sure whether this arithmetic operation have been done in the chapter in your syllabus or not. But hopefully I can help on this one. And there is no photo session for today. Maybe tomorrow.
Yeah, maybe tomorrow I will to make maybe a 80% of the student will attend. Yeah, so I want to all of them to on cam and we can to take a picture together. Okay.
Okay, all right. Thank you. Thank you very much.
Okay.
Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh, Dr. Norma.